Hello students, welcome to PhyZiVibes. Today we are going to discuss some questions from IRODOVE based on concept work, power and energy. So here is our first problem. So in this problem it is given that a body of mass m is acted upon by a force F is equal to 2 ay minus 1 mg. Then we have to find work performed by this force and the increment its potential energy over half of the ascent. Now here there is one catch, that in IRODOVE this force is written in bold letters, and we know if something is written in bold letters then it is actually vector. So this G is also written in bold letter and F is also written in bold letter. And if we consider that A and Y are also written in bold letters, then meaning of this is something like this. It means something like this. So this force we can write as 2 ay minus 1 m, and to G if we give direction, since we know G is acting towards downwards. So this force now we can write as 2 mg 1 minus ay j cap. So j cap is representing direction, and now this represents that this force is acting upwards and mg is acting downwards, and there is some net force on this body, which we can write now as F net is equal to this F applied minus mg. This F applied is 2 mg minus 2, just a minute, 2 mg minus 2 mg ay and minus mg. Now net force is mg minus 2 mg ay. So initially as y is 0, we can see here that net force will be mg, and as body ascends up, let's say this was ground level and this is y height from ground. So as body ascends up, this net force is decreasing. At some point this net force will be 0. When ay becomes 1 by 2, net force on this body will be 0. So here's additional information that at ay is equal to 1 by 2, F net will be 0. So we can also ask one additional question here, that at what height this net force becomes 0. So when net force becomes 0, by that time body has attained some velocity, and because of that velocity it will continue moving upwards and will eventually reach up to a certain maximum height. So here question is asked that you have to find increment in potential energy and work performed by this force over the first half of the ascent. So first of all we will have to find total ascent, and then we will have to find work done in half of the ascent. So let's get started with what will be the total ascent. So this net force we can write as m into a, that will be mg minus 2 mg a y. You can cut this m, and we know that we can write acceleration. Now this a is constant a, and here in F net what acceleration is written is ACC. So we know that acceleration is v dv by dy, that is equal to g minus 2g ay. Now v dv is equal to g minus 2g ay and dy. Now we can integrate this equation. We started from ground, so y was 0 initially, and we started from rest, so velocity is also 0. At height, when ay is equal to 1 by 2, velocity is maximum, but we will continue moving upward from here also. So at maximum height h, will momentary come to rest, so at that time velocity will also be 0. So at maximum height again we will be at rest, so velocity is from 0 to 0. Now if we integrate v, you will get v square by 2, but when we will keep limit 0 to 0, it will become 0. Solving this, what we get is g y minus 2ga y square by 2 and limit 0 to h. Now this becomes 0 is equal to, when we put limit, this becomes 2ga h square by 2. Now you can cut this 2 and 2, and now you will get a gh is equal to ga h square. Cutting down g and h, you will get ah is equal to 1 or h is equal to 1 by. This is maximum height up to which body will ascend. And now you have to find work done by this force F up to half of the height. So now we know that work done by a force, work done by any force is F dot dy. Since this body is ascending up, angle between F and dy is 0 degree. So we can directly write value of force, magnitude of this force, which we know is what is this much quantity only, 2 mg 1 minus ay. So it is 2 mg 1 minus ay and dy, and we have to find this work done from height 0 to half of the maximum height, that is h by 2. Now we will integrate this, so we will get work done by this force, and it will be 2 mg. You can take out this constant quantity, and integration, on integrating we will get y minus a y square by 2, limit 0 to h by 2. So it will be 2 mg, at place of y you will get h by 2 minus a by 2, and y square is again h square by 4. Solving this, we will get 2 mg 2 mg h by 2 minus a by 4 2s are 8, and h square, we know value of h is 1 by a, so it will become 1 by a square. Now you can solve this. 2 mg and value of h is also 1 by, so we'll also put here h is equal to 1 by a. So what we are getting is 1 by 2a and 1 by 8a. So 8a is the LCM, 4 minus 1, and on solving you will get 2 mg 3 by 8a, or simply you can write it as work is equal to 3 mg by 4a. This is our answer. And there was one more question, that you have to find increment in the potential energy. You have to find increment in the potential and gravitational potential energy over first half of the ascent. So we know that increment in the gravitational potential energy is negative of work done by gravitational force. So increment in potential energy will be negative of work done by gravitational force, and basically its value is mg, half of the ascent is h by 2. So you can write directly its value, that is mg, h is 1 by a, so that is 2a. So this is our second answer. Okay, let's move to second question. So this is our second question. Here it is asked that a it is given that a particle is moving in a circle with normal acceleration varying as, it is given as an, this is normal acceleration as a t to the power 2, where a is constant. You have to find time dependency of power developed by all the forces. Now this particle is moving on a circular track of radius r. So this is circular track of radius r, and the particle is moving on this circular path. So when particle is moving on a circle, then we have one acceleration called tangential acceleration, and we have one acceleration called centripetal acceleration. Now because of this tangential acceleration, there is a force, we can call it tangential force, and because of the centripetal acceleration, we have force called centripetal force. And basically net force is vector addition of these two forces. Now this is your F net, where what is F net? This F net is vector addition of tangential and centripetal. Now let's say angle between this F net and tangential is theta degree. Now as tangential as normal acceleration, now we know what is normal acceleration. Normal acceleration is v square by r, where v is speed. The particle is moving along tangent, so its speed, its velocity is along tangent. Now one, we are given normal acceleration is at square. We know normal acceleration is v square by r. So taking this 1 and 2, what we will get is v square by r is equal to a t square, or what we can write to v. Now v is speed, basically is a r t. Now if this is speed, now we know that tangential acceleration is basically rate of change of speed. V is speed and its rate of change will give us tangential acceleration. So dy dt under root of ar into t, which is coming out to be under root of ar. So we can see that tangential acceleration is constant. If tangential acceleration is constant, then tangential force, that is m into tangential acceleration, will also be a constant quantity. So this is tangential acceleration. Now we have to find power. Question is, you have to find power developed by all the forces. So power developed by all the forces means power developed by net force. Now we know that power, instantaneous power P is F dot V. The power of a force is F dot V, and we have to find power of net force. So we'll do this. Now from this figure you can identify that F net cos theta is basically tangential force, and F net sin theta is basically centripetal force. So we have to find power of net force, and you know that F dot V will be F net cos theta into V. This is the result of dot product, and F net cos theta we have just identified as tangential force. So this is Ft into V. So this is quantity which we have to find. So power will be tangential force, we have just found out to be m under root of ar, and we know V, that is speed, is under root of art. So from V we put under root of art. This is V. On combining all this, we will get power is equal to m, a, r and t. So this is instantaneous power. Now next part of the question is, you have to find average power over the first t second. So as we know that average power is total work by total time. Is total work by total time. Total time is T, and total work of net force. The work of net force is basically F net dot dl by total time is T. Now what is net force? Now as we know that this is net force, and what is the meaning of dl? Dl meaning infinitesimal path which you have traveled in time dt. So in time dt we are traveling this distance, that is dl. So dl is acting along tangent. So when dl is acting along tangent, what you can conclude from here is basically this F net is F net cos theta into dl. This is angle between F net and dl. So this is your total work done by total time is coming out to be T, and we know that F net cos theta is again tangential force which is constant. So this is tangential force into dl by T. Tangential force, since this is constant, you can take out it, and this is dl by T. Now what is dl? dl is total distance covered by particle in time t over this circle. So let's say particle travel some distance over this circle. Let's say this is that distance. It travels some distance starting from here, let's say. So what will be this distance? So you can use formula. You can use formula S is equal to ut plus half at square for this, where this a means rate of change of speed, which is basically tangential acceleration. So this displacement will be L. U was 0. Half tangential acceleration we have just found out to be root AR. So this is root AR and T square. So integration of dl is L, which is this quantity. So this is 0, say L. And tangential is M into A tangential, and this is L and divided by T. So M by T, A tangential is root AR, and value of L is root AR T square by 2. Solving all, what we get is average power. Average power is M AR T by 2. So this is average power over time T. So thank you for watching this video. Please consider subscribing this channel for more related videos.